Assalamualaikum warahmatullahi wabarakatuh. Today, we will present about the composite material for marine applications. Key challenges for the future under the subject Composites and Advanced Material. There are 6 members in this group. First is Muhammad Sazwan bin Muhammad Aziz. Second is Muhammad Haris bin Mazlan. Third is Muhammad Hafiz Hakimi bin Sa'arin. Muhammad Adam Ikmal bin Ahmad. Muhammad Haziq bin Hazani. And the last is Rabiatul Adawiyah binti Mustafa. Our lecturer is Dr. Siti Hajar Sheikh Muhammad Fazlullah. The introduction of our topic is polymeric composite materials have been used in boats, ships, submersibles, offshore structures, and other marine structural applications. Key challenges for the future is the twofold. First, need to ensure that capital expenditure and operating costs on an economic front of the ships, boats, and other marine artifacts. Second is the important to appreciate and understand life cycle issue from the environmental impact viewpoint.
Next, the main features of composite materials used in marine application. First, ferrocement. Ferrocement members are durable and versatile material. It has low W/C ratio and produces impermeable structures. It has less shrinkage and weight. The structures have high tensile strength, stiffness, and rigidity. They have a better impact and punching shear resistance. Ferrocement members undergo large deformation before cracking. Second, aramid fiber. Aramid fiber has high strength, good resistance to abrasion, good resistance to organic solvents, non-conductive, no melting point, low flammability, good fabric integrity at elevated temperatures. Third is carbon fiber. Carbon fiber has ultra-high modulus, type UHM, modulus more than 450 gigapascal. Carbon fiber also has high modulus, type HM, modulus between 350 to 450 gigapascal. Intermediate modulus, which is type IM, modulus between 200 to 350 gigapascal. Carbon fiber also have low modulus and high tensile, type HT, modulus less than 100 gigapascal, tensile strength more than 3.0 gigapascal. And lastly, carbon fiber has super high tensile, type SHT, tensile strength more than 4.5 gigapascal. Fourth is glass reinforcement plastic. Glass reinforcement plastic has high tensile strength, dimensional stability, good thermal conductivity, great fire resistant, good chemical resistant, great durability, and highly economical. And fifth, wood or adhesive composite. Adhesive composite has abrasion resistant, creep and fatigue resistant, dimensionally stable, flexibilized and toughened, hardness, low shrinkage, low stress, rigid curing, high strength, has vibration, impact, and shock resist.
Okay, now I will proceed with functional requirement for the specific application. The first functional requirement is structural weight. One of the most important requirements in using specific type of material is the characteristic that it has to fulfill the marine application requirement. When dealing with marine applications such as ferries, cargo vessels, and ships, using lightweight material is very important to make sure that many loads can be filled, greater speed can be achieved, and lower fuel consumption. The example of lightweight composite material is fiber reinforced polymer (FRP), which offer potential savings in structural weight and already applied in the construction of boats and small ships. The next requirement is high strength. By using composite materials, it can contribute to boost the performance and minimize the risk of failure in extreme sailing conditions. In order to achieve minimization of risk of failure in extreme sailing conditions, the composite material must have high strength to withstand the strong and wavy sea wave. One of the material that suit this application is aramid fiber. Aramid fiber has highly oriented chains. Molecules among the fiber exist, which resulting to higher proportion of chemical bond that contributes to stronger fiber strength than other synthetic fibers. Aramid fibers already been used in racing powerboats to protect the driver in all conditions, especially in high-speed crash. The next requirement is high corrosion resistance. Salt water can corrode metal 5 times faster than fresh water does. Therefore, it is important to use high corrosion resistant material in marine applications to make sure that it can be used in long terms. An experiment was carried out to prevent corrosion in aluminium metals. When the experiment was completed, it was evident that the functional role of nickel oxide and cerium oxide in metal matrix composite in maritime engineering was essential, as evidenced by electrochemical, psychochemical, and structural evaluation. The best proportion of nickel oxide and cerium oxide in aluminium metal matrix composite is 0.4% for each of it. So we can use aluminium metal as a barrier protection to resist corrosion. The last requirement is ductility. The property of a material to be distorted before it fails due to tension is referred to ductility. This feature is temperature dependent and decreases as the temperature rises. Gold is one of the most ductile metals, but since we are talking about shipbuilding, ductile materials like tin, zinc, lead, and copper are used. Notch ductility is a similarly related phrase that refers to the relative toughness of steel as assessed by an impact test.
My name is Muhammad Hafiz Hakimi Bisarin. I will share about the limitation for my group topic, which is about the composite materials.
So, for the last part is overview of the past, present, and future application of the composites in specific area. As an overview, there is definite future for the continuous and rising usage of polymeric composite materials for structural maritime applications. Industry is very interested in novel methods to utilize current materials as well as new and existing materials in new applications. Next, the performance of structures in maritime boats must be improved on a regular and consistent basis, which will be driven by safety and quality concerns.
Next, economic restrictions will also play an increasingly important role in the future, necessitating the development of concurrent engineering methodologies. Fifth, life cycle evaluation of composite structures is also necessary in order to better understand and appreciate the environmental effect of their use. And the last one is structural health monitoring, as well as the accompanying inspection, intervention, and repair procedures will become more crucial in order to maintain the safe functioning of maritime composites, while also maximizing and extending the life of these components. So that's all. Thank you.